Welcome to Chapter 1, The Art and Science of Data, Section 1, Where Does Data Come From? Now, there's a couple of things that you can do while watching this video. You can listen and answer the questions from Edpuzzle and take your own notes as you go along. Again, pause if I start talking too fast and you need to write something down. Or I'm going to include this PowerPoint in the Google Classroom. You can go to File and go to Print. And then I wouldn't suggest printing all, there we go. I wouldn't suggest printing full pages because that's going to take a lot of paper. But if you do 6 slides horizontal, you can do 9 slides so that you can kind of take notes off to the side of the presentation and you don't have to write down everything that's in the slide. Or again, you do not have to print anything. You are more than welcome to just take notes on your own paper. And I'm going to hide this. Okay, here we go. So let's start the presentation. Have you ever wondered how data is produced? For example, in the year 2007, 12.5% of drivers involved in fatal crashes were 15 to 20 years old, according to NHTSA, the National Highway of Traffic Safety Administration. Well, that's a pretty trusted source, the National Highway of Traffic and Safety Administration. I'm going to trust that what they're talking to me about, this fatal crashes statistic, is a true statement. Example 2. According to researchers in the Netherlands, people who are 30 or more pounds overweight could use 7 years from their life expectancy. Whoa, what researchers? I'm not going to take that at face value. I'm going to look at that some more because what research are they talking about? Have they done an experiment? Are they just observing things that they've seen? Is this based on their personal experience? I don't know that this is a true statement. Example 3. A major medical study conducted, that doesn't say conducted, that says concluded, that taking aspirin regularly will reduce the risk of a heart attack. Okay, now if my doctor is suggesting that I take aspirin every day and he references a major medical study that he knows of or she knows of, I might consider taking his advice and taking aspirin every day to reduce the risk of a heart attack for myself. Now, I got this statement from a commercial for Bayer aspirin. Now, on a commercial, if I hear a major medical study concluded, I'm going to think, what study? How did they collect their data? Did they collect it in a good way? And I'm going to go and I'm going to talk to my doctor about this. I'm not going to just start taking aspirin to reduce the risk of a heart attack. Okay, I'm going to consult with my doctor because could the Bayer aspirin company just be trying to increase their revenue? You know, I'm going to kind of take that with the information that I have and then get more. All right, for example, number 4, Dr. Newman thought that cell phones caused brain tumors based on his own personal experience. The rest of the sentence, I couldn't fit it all in there, is that his wife had a brain tumor and she was constantly on the phone. Now, even after several scientific studies have proven cell phones are safe, there's still some that doubt that cell phones are really safe. Because Dr. Newman is a doctor, right? He has some trustability just in the fact that he has gone to medical school and is a doctor. And if a doctor tells someone that this is what's true and this is what's going to happen, that people tend to believe it. Now, if he was basing his thoughts on research, that should be a true statement. However, he wasn't basing his thoughts on research. He was basing his thoughts on, I don't know how to pause this. Okay, I'm just going to quiet that for a second. He wasn't basing his thoughts on research. He was basing his thoughts on something that happened in his life. Okay, so it might not be true. Okay, we have to think about these things. We should always ask, where does the data come from? All right. Can the source be trusted? Good data takes time and a great deal of effort to collect correctly. We're going to spend the entire school year talking about how to collect good data. It's not something that is easy and fast to do. Bad data can be generated through laziness. Okay, I just want to collect and generate some sort of data. It could be collected through lack of understanding. Maybe I don't really understand what it is I'm collecting data about, and that leads the data to not be 100% accurate. Or maybe there could be a desire to mislead people with data. All right, here we go. Some definitions. First one is an individual. Okay, make sure if you haven't written anything down in your notebooks at this point, you're going to want to write this down. You want to write because you're going to come back to these over and over again. First, individual, write it down, underline it. Here's the definition. An individual are objects that are described by a data set. Objects are people, places, animals, or things. They're your nouns in the data. The variable. The variable is a characteristic of an individual. Okay, so if I look at this data set, I want to ask myself, what are the individuals, or who are the individuals? Okay, so I'm going to look and see the individuals are these people. You can't see if I point at my screen. I forgot. Okay, I'm going to use my mouse. There we go. The individuals. There's some sort of like highlighter thing. I have to like figure out how to make that work. I'll do that for the next video. In this example, what are the variables? So what things are describing these people? Okay, so the people are my individuals, and the job type, these are describing what these people do. The age is describing how old these people are. The gender, male or female, is describing whether these are boys or girls. The race is describing what race they are. The salary describes how much money they make. So the variables are these 5 topics. Measurements are made on an individual and organized into variables. Okay, so write down the definition of an individual, write down the definition of a variable, give yourself some examples over here on each of these so that you know what it is that you're looking for when you do this for a problem. There's 2 types of variables. There's a categorical variable, which places an individual into one of several groups or categories. The answers are words or numbers that cannot be averaged. So anything that has words, okay, or anything that cannot be averaged. So for example, zip codes. If I have the zip code 78626 and 78628, those are numbers, yes. But if I averaged them, would 78627 make sense in terms of Georgetown? No, because there is no zip code 78627. So that would be a categorical variable. My zip code places me in a section of Georgetown. It gives me a location. It's not something that we can average, so your zip code is a categorical variable. Okay, quantitative variables are numeric values for the arithmetic operations that make sense. The answers are numbers that can be averaged. Okay, so in my example that I gave earlier, we have, let's see, what do we have? What are the categorical variables? Okay, so categorical variables are answers that are words or numbers that can't be averaged. So job type was my variable. Do I answer the job type with words? Yes, so that's categorical. The age is numbers. Okay, those can be averaged, not a categorical variable. Gender, male, female, those are words. That's categorical. Race, white, black, those are words. That's categorical. Salary, these are numbers. Can I average the salary? Yes, so that's not categorical. Okay, so categorical variables are job type, gender, and race. Quantitative variables are numbers that can be averaged. So age is numbers, and I can average it. Salary is numbers, and I can average it. So those are my 2 categorical variables in this example. Okay, let's look at another example, the hotel problem. And you can see the questions right down here at the bottom. What individuals does this data set describe? So the hotel, and then it says pool, exercise room, internet, restaurants, distance to competition, room service, and rooms rate per day. All of these things are used to describe the hotel. So the hotels are the individuals. These things are my variables. Okay, now let's identify the variables and which are quantitative. So I'm going to look at the answers that I get. So if I ask, is there a pool? I get words. If I get words, that's a categorical variable. The answers to exercise room are yes and no. Those are words. So that makes that a categorical variable. The answers to internet dollars per day are numbers. Can I find an average of how much internet costs me per day? Yes. Therefore, that's a quantitative variable. The answers to restaurants are 1, 1, 1, 0. Those are numbers. Can I find an average number of restaurants? Yes, that's quantitative. Distance to competition, 8.2, 8.3, 3.7. Yes, miles are words, but that's more of a label, not an answer. The 8.2 is the answer. Can I average that? Yes, those are numbers that I can average. So this is quantitative. Room service. Answers are words. So I can, sorry, my phone keeps ringing. I'm going to turn that down. The answers are words, so that makes that a categorical. Room rate, dollars per day, those are numbers. So if they're numbers and I can average them, it makes it quantitative. Okay, ways to collect data. Let's see. We have an observational study, and there's 3 types of observational study. We can either compare them, we can use sampling, or we can create or conduct a census, and I can do an experiment. All right, so let's look at all of these ways to collect data. I feel like I missed something on the last one. Hang on a second. Oh, I did. I knew I missed something. On C, it says, if you were a debate team member, which hotel would you recommend and why? Okay, now this is subjective. All right, so as long as you give me an answer to these types of questions and your answer is reasonable, there's more than one correct answer. So for example, I can say that I'm going to stay at the Fairfield Inn and Suites because the room rate is the least amount of money. And I can't see the other ones. I have no idea what they say underneath. Okay, so this 119 is less than 149, so that's why I want to stay there. Or I can say, even though Marriott is more expensive, it's at my competition and I wouldn't have to take a car to get there, so I want to stay at the Marriott. As long as you have a reason why you recommend it, there's more than one correct answer. Okay, so let me get back to this, ways to collect data. An observational study observes individuals and measures variables of interest, but does not attempt to influence the responses. Think I'm a fly on the wall. I'm not doing anything to anybody. I'm just sitting there and observing. I'm just watching and writing things down. Okay. When the principal comes in to do an evaluation of me, she's doing an observational study. She's not interacting with the class. She's not doing anything to see what would happen. She's just observing how I conduct class. That's an observational study. The purpose is to describe a group or a situation. The purpose for Miss Easter coming in to observe me is to determine whether or not I'm teaching well or not. Must be organized and measure clearly defined variables in order to be convincing. Okay, so there are certain things that she's looking for and she's making observations on while she's observing me. For example, okay, I already gave you this Easter example, but for another example, traffic pattern studies. If there is, so sometimes, you drive down the road, you see that little black wire that's all the way across the road. Well, that's attached to a box, and that counts how many cars go past that on the road. And it also counts like how fast it is from the first tires crossing that line to the next tires crossing the line. And it can tell you how fast you're driving. They can use that to determine what the 85th percentile of drivers drive on that road to help set the speed limit. We'll talk about what percentile and what that actually means a little bit later in the school year. But they're not doing anything to your driving habits. All they're doing is recording A, you're on the road, and B, how fast you're going. That's it. Just making those observations. A comparative observational study is when I compare the results of one observational study to the same observational study during a different time or a different place. So for example, if I go to the parking lot, in the student parking lot, and observe how fast students drive in the morning compared to how fast students drive in the afternoon, I can make a conclusion and just kind of make an observation about whether or not they drive differently in the morning or in the afternoon. Again, I'm not doing anything to affect how they drive. I'm just sitting there writing it down. Example 2. Observe the types of cars that students drive in the parking lot at Eastview compared to the students driving at Georgetown High School. Is there a difference? I don't know. I don't know if there would be or not. But I can observe the different parking lots. That would be, and then I can compare them. That would be a comparative observational study. The next type of observational study is sampling. And the idea of sampling is to gain information about the whole by examining only a part. So, again, this is something you want to write down. The population is the entire group of individuals that information is wanted about. It's your whole. So it's what I'm trying to gain information about. I want to know something about the whole. The sample is the part of the population from the information that is collected. It's your part. So for example, in this lemonade, all right, the pitcher of lemonade, this pitcher of lemonade right here is my population. The cup of lemonade is my sample. If I want to know how the lemonade tastes, do I need to drink the whole pitcher, or can I just taste the cup to know how it tastes, right? Whether it's sour, whether it's sweet. Okay, I can know a lot about the whole pitcher of lemonade from just having a small cup. All right, so what is the population and what is the sample? Let's look at an example. A business school researcher wants to know what factors affect the survival and success of a small business. She selects 150 restaurants from those listed in the phone book. The population is all of the small businesses. That's my whole. The part is the 150 that she selected to interview. I'm using these 150 to draw conclusions about all of the restaurant businesses. A census. A census is a sample survey that attempts to include the entire population in the sample. So, in my lemonade example, if I was going to take a census of the lemonade, I would be drinking the whole pitcher of lemonade. If this is my population, a sample is a part of that population. A census is the whole population. I would be asking everyone in my group. There are some drawbacks to a census. First, it's very time consuming. It takes a lot of time to ask all of those people the question. It's expensive. Okay, whenever you're talking about time, we're talking about money. All right. Instead of just having to ask 5 people, now I have to ask 500 people. That takes a lot of materials. That takes a lot of resources. I have to hire more people. It's very expensive. And even if I have the resources of the federal government, every 10 years they actually do a census. They're working on one right now for 2020. It's still very difficult and we can still miss people. An experiment. An experiment deliberately imposes some treatment. Okay, there's that word is bolded and highlighted and trying to stand out and jump at you for a reason on individuals in order to observe their response. The treatment is the difference between the experiment and the observational study. We're both observing the responses, but in an observation, we're just observing. In an experiment, I apply a treatment and then observe. Okay, so when I'm looking to decide whether it's an observational study or an experiment, I'm looking to see, is there a treatment being applied? The purpose is to study whether a treatment causes a change in the response. We need a control group to make comparisons. And this is big because it comes up lots on tests. This is the test question on, I think, 3 or 4 tests over the years, over the school year. Experiments can offer a cause and effect relationship. Okay, if I do in a proper experiment, I can prove without a reasonable doubt, that this causes that to happen. In an observational study, I can just say that there's a relationship between the 2 variables. I cannot, I repeat, not have a cause and effect relationship. The only thing that can prove cause and effect is an experiment. All right, so let's look at these pictures. Is it an observational study or is it an experiment? All right, so in this picture, we've got the little monkey and the daddy monkey or the mommy monkey saying, okay, let's eat our bananas. The experimenter or the observationist is back here watching. Is she doing anything to the monkeys? No, she's just sitting there. She's the fly on the wall. She is observing. It's an observational study. Okay, baby throws toy. Toys don't bounce. That's the end of that experiment. Is baby doing something to see if the toys will bounce? Yeah. He is throwing them out of the crib. This action is the treatment of the toys, right? That's your experiment. We're not just observing to see whether the toys bounce. We did something to the toy to see if it would bounce. That makes this an experiment. All right, let's do a couple more examples. Before tasting a variety of muffins, so that's not what that says. Let me start over. Let me read what it actually says. It says, before a new variety of muffin is put on the market, it is subjected to extensive taste testing. People are asked to taste the new muffin and competing brand and to say which one they prefer. Is the person doing this study changing anything or giving them any sort of treatment? Or are they just observing which one they like better? They're just observing, which makes this an observational study. Okay, researchers gathered in a small group of dental patients. I really can't read because that's not what that says. Researchers gathered a small group of dental patients, and on one side of the patient's mouths, they applied bleaching gel, and on the other side, they applied bleaching gel and used the light to activate it. They are trying to determine if the light enhances, I forgot an S, the bleaching gel to improve teeth whitening. Are they doing something to this bleaching gel to apply a treatment, to test? Are they testing something? Yes. The bleaching gel on one side is by itself. That's your control. The light is your treatment on the other side. We're trying to see, does the light enhance the bleaching gel? So this would be a experiment. Okay, an experiment. I got to use the right words here. So the light is the treatment. Half of the students in the classroom are going to be given a red shirt, and the other half will wear white. Then we're going to release a swarm of bees and see whether you get stung more with a red shirt or a white shirt. Whoa, this is not ethical. We can't really do this. Okay, so let's just talk about this hypothetically, because this would not be something we would do in real life. It's very unethical. Are we doing something to give some sort of treatment to the students? Are we controlling something in the experiment, or are we just watching to see who the bees sting? We controlled it, okay? This red shirt right here and the white shirt are a control. Those are a treatment. We've put something in place to see what's going to happen. Okay, if we had just said we're going to release a swarm of bees and see whether you get stung, what color shirt gets stung the most, that would be observational. I didn't apply a treatment first. This red shirt and the white shirt, because I forced people to decide what they're going to wear, that makes it a treatment. Again, if this just said, I'm going to release a swarm of bees and see which color shirt gets stung the most, that would be observational because I'm not doing anything really. I'm just watching. Okay. All right, time to take the quiz, and we are done with this video. Thank you. Let's see if I can stop this. Okay, it's still recording. It's still recording. All right, how do I stop it? Okay, desktop is being recording. I want to